Well. Welcome to this YouTube channel. This is David Kareche, serving the Lasallian Institute here in Rongai Boys. I take this opportunity to thank you for subscribing to this YouTube channel. If you are a first-time viewer, subscribe to this YouTube channel by pressing on the subscription button, like this video, and click on the notification bell so that when I release more videos, you'll be notified in good time. Today, we go on delving into this subtle and very elusive matter called the atom. It is a very intriguing and very fascinating topic on the structure of the smallest indivisible particle of matter called the atom. The idea that matter is made up of small particles called atoms dates back in the ancient Greek times in the 5th century BC. And the Greeks had an idea of how an atom looks like. The Greek atomic model is uniform, solid, and incompressible particle that is indestructible. This notion was borrowed by the first scientists to talk about atoms, and this is the father of modern chemistry called John Dalton. In the Dalton's atomic model, he thought an atom is solid, uniform, incompressible, and indestructible billiard ball that could not be split into smaller particles. By the time when Dalton was proposing his atomic theory, the subatomic particles had not been discovered yet, and he considered the atom as the smallest indivisible particle of matter. However, the structure of the atom has been refined from one age to another with the discovery of the electron in the year 1897 by J.J. Thomson, working in the Cavendish Laboratory in Cambridge University. He proposed his atomic model resembling a plum pudding, where he opined that an atom is spherical in shape with a sea of positive charges in which the electrons were embedded. By that time, it had not been discovered that the atom was nuclear in nature. His atomic model was refined by yet another physicist who was his student, a New Zealand-born physicist in the name Ernest Rutherford. According to Rutherford, an atom is like a miniature solar system with the solid core being at the center of the atom, with the electrons revolving around the nucleus, just the way the planets revolve around the sun. And that's why Rutherford nuclear model, sometimes referred to as the nuclear atomic model or the planetary atomic model. His atomic model was further refined by yet another physicist, Niels Bohr, a Danish-born English physicist. He opined that the atom has a solid core called the nucleus, where we find the protons and the neutrons. And this is where most of the mass of the particle is concentrated, with the extranuclear space where the electrons will occupy certain energy levels, of which he named them energy level number 1, 2, 3, and so on, or represented by letters K, L, M, and so on. And he opined that the electrons could occupy only one energy level at a given time, and the electrons are to occupy the lowest energy levels. However, if an atom absorbs energy, the electrons absorb the energy and jump to higher energy levels. So when they are occupying their normal energy levels, they were sent to occupy their ground state. However, if they jump to higher energy levels, they were sent to be in excited state. And as the source of energy evades, the electrons would jump from higher energy levels in their excited state to lower energy to their normal energy levels in their ground state and emit energy. The Bohr's atomic model was further refined and was followed by the present atomic model that we are going to have, and this is what is referred to as the electron cloud atomic model or the quantum mechanics atomic model. So in this model, the electrons are going to occupy regions that we refer to as orbitals. So in the first energy level, we only have the s orbitals. In the second energy level, we have the s and the p orbitals. In the third energy level, we have the s, p, and d orbitals. And in the fourth energy level, we have the s, p, d, and f orbitals. Due to the complex nature of the electron cloud or the quantum mechanics atomic model. We will delve in that in our next episode. And I thank you for subscribing to this channel. And thank you, and you are most welcome.